3.6, graphing a quadratic inequality and looking at the solutions. So in this section, you're going to have to remember a couple things about graphing inequalities. First of all, when you graph an inequality, you use a dashed line for inequalities with less than or greater than, and a solid if it's an equal to. Then what you're going to do is test a point, any convenient point xy, and see if it satisfies the inequality. And then you're going to shade either toward the point or away from the point. For example, if you look at this equation, this inequality, it's less than, so you have to remember to dash it. But the question really is how do you graph this particular graph? So you're going to look at negative b over 2a to find out what the vertex is. That means it's a negative 2 over 2 times negative 1. And that equals 2 over negative 2, which equals negative 1. Therefore, your x is negative 1. And if you put negative 1 in for x and determine what your y is, you can just treat it like it's an equal sign at this point. Let's see, negative 1 squared. And that is equal to, this becomes 1, negative 1 plus 2 minus 1, which is equal to 0. Therefore, the point is negative 1, 0 is your intercept and your vertex. Notice that it's negative, so it's going to be graphed down. And by plugging in a couple points, if I were to look at 0, I would get negative 1. It's symmetric, so you know it's got to be that point as well. If I plug in 1, let's see, it's going to be negative 3, negative 4. So that's going to be another point. And that's going to give you the general part of the parabola. However, I've got to remember that it's less than, so I have to remember to dash it. Easy to remember. If you draw in a solid line, you can just go back with an eraser and then dash it. So at this point, the question is, well, I need to test one point. Normally, if 0, 0 is not on this graph, then you would go ahead and test that point. So is 0 less than or equal to 0 minus 0 minus 1? Is 0 less than negative 1? That answer is no, it's greater than it. So this point right here does not work, meaning all of these points on the outside of the parabola do not work. Which points do work? The points on the inside of the parabola. So all of these points that I'm shading are actually solutions to this inequality. There's an infinite amount of points that satisfy that inequality. Now that's just one inequality. You could also have two inequalities. For example, one inequality is this one. And so if I were to think of it as equal, it would just be up 3. I could use transformations on this one. And it's going to be going down. So a couple of points. If I put in 1, I'm going to get 2 and 2. So that means that I know that these points are on that parabola. And if I were to go to 2, it would be, let's see, negative 4, which is negative 1. So that means that it's going to be right here. And that's going to be the first inequality that gets graphed. And again, I'm showing some points there. Now the second one is a little bit trickier, so I'm going to do negative b over 2a. Use a different color so you can see, keep the two separate. And so that's equal to a negative 2 over 2 times 1, which equals negative 1. So -1, and if I put -1 in, I get y is equal to -1 squared. And I end up getting -5, -1, -5, which is this point right here. Now it's an equal sign, so it's going to be solid. It's going to open up, and now you want to test a point. 0 is going to be the easiest point. 0 is at 3, so -3, so that's 1 point. By symmetry, that's going to be the other point. And maybe if I put in 1, that's also a convenient point. So if I put in 1 plus 2, you get 3 minus 3. That's going to give you this point right here. And that point, and therefore that graph is going to go, oh, it's hard to draw on this pad, but you get the general idea. Ooh, not the best. But anyway, all of the points, either shared or not shared, are going to give you the answer. So now the question is, okay, well, I've got to figure out where the inequalities are true. If I use 0.00 on both of them, let's see what happens. Is 0 less than 3? Yes, it is. Is 0 greater than or equal to -3? Yes, it is. This satisfies both of those inequalities, means we shade to that area. Now, when I do the purple one, the shading actually is all of this area, right? It's, whoopsies. Oh no. There. All of that area, which means that it looks like that. And if I were to do the red one on the shading, it's going to look like this, where it comes down all the way through here. So what is the actual solution? It's where they intersect. That means the intersection is going to look like this. Solid line to here, dashed line up through here, and all of the points right in here. Not the best graph, but you get the general idea. And just forgive me for the inaccuracies because I'm working with a pad here. So that's solving a system of inequalities by graphing, and the solution is going to be an infinite number of solutions.